Hello, everybody, and welcome to the Reuse Company webinar. The webinar will start in a moment. You will be muted during the webinar, but if you have any questions or comments, you can use the chat box. But please address your comments to the Reuse Company and not to the presenter. If you have any technical issues, please use the chat box, or you can also send an email to support@reusecompany.com. The webinar will be recorded, and in a few days, we will send you the link to the recording. Okay, so let's start with the webinar. Writing requirements with a knowledge library based on the NASA Systems Engineering Handbook. My name is Cecilia Karlsson, and I will be hosting today's webinar. With me today, I have my colleague Luis Javier Munoz, and he will tell us how to write requirements according to the NASA Handbook. This is the agenda for the webinar. First, we will have a description of the company and the presenter. Then Luis Javier will talk about the NASA Systems Engineering Handbook and the Ontology Library. We will take a look at the Systems Engineering Suite, and Luis Javier will do a demonstration. After that, we will have some time for questions. Okay, so first a few words about the Reuse Company. Our mission is to provide a knowledge-centric approach to leverage systems engineering activities for our customers. The Reuse Company was created in 1999, and it's a spin-off from a university in Madrid. It was created by system and software engineers. Our headquarters is in Madrid, but we also have offices in London and in Stockholm. Since the company is a spin-off from the Carlos III University of Madrid, research and innovation is in our DNA, and about 10% of our revenues are dedicated to research and development. The Reuse Company is also actively involved in several large European research projects, like, for example, Arrowhead, Embrace, and PE Control. The Reuse Company is also called GRC. We like to say that it's easy to remember if you think of G like in traceability, R like in reuse, and C or almost Q like in quality. So who is using our technology? Here you can see some of the companies that are users of our system. They come from quite different industries, like aerospace and defense, energy, automation, and healthcare, but also from other industries. Now let me introduce you to the presenter. Luis Javier is a sales and consulting engineer at the Reuse Company. He has experience in aeronautics engineering and systems design in different industrial sectors such as aeronautics, defense, and space. Luis Javier is working with international sales of our systems engineering solutions, consulting, and account management. His main interests are knowledge management, aerospace engineering, requirements engineering, and systems engineering processes. So let's start with today's topic, writing requirements with a knowledge library based on the NASA Systems Engineering Handbook. We hope you will like it. Please.
All right, Cecilia, thank you very much. Thanks for your introduction. Hello, everybody. Welcome to today's webinar. As Cecilia says, we are going to talk about how to write requirements based on a library focused on the NASA System Engineering Handbook. So first of all, I want to talk to you something about the handbook. This NASA handbook was created after some events and some reports by the NASA Office of Chief Engineering. They took this initiative to improve the overall agency system engineering infrastructure and capability to do an efficient and effective engineering as an assistant. The book, the handbook, was initially wrote back in 1995, and the latest version is from 2016. The main objective of this handbook is to provide general guidance and information of system engineering for the agency, and to bring fundamental concepts and techniques of system engineering for all the NASA environment. NASA defines system engineering as a methodological multidisciplinary approach for the design, realization, technical management, operation, and requirement of a system. Being a system, a combination of elements that function together to produce the capability required to meet a need. So in the NASA handbook, in the paragraph 4, they identify four design processes: shareholder expectation, requirement definition, design solution definition, and logical decomposition. Inside of the requirement definition, they distinguish this process to transform the shareholder expectation into definition of the problem, and at the end into a complete set of validated technical requirements. So this is the focus of our webinar today, is this set of technical requirements. In the handbook, they express some ideas or some guidance about how those requirements have to be collected and right. In this section, 42123 define if the requirement is in an acceptable statement. It says that the requirement should be defined in acceptable shall statement, which are complete sentence with a single shall per statement. Rationale should also be captured to ensure the relation of the context and of the requirement is understood. And also the handbook has a specific appendix, Appendix C, of how to write a good requirement, and including a checklist. In this appendix, you can see here the section. There are several paragraphs talking about the characteristic of good requirement, and even a checklist of how to ensure and verify that the requirement is appropriate. From this appendix and from the information wrote in this paragraph, we have extract a guidance and characteristic of the requirements according to the NASA handbook. Well, the handbook also consider what is the impact of poor quality requirements, talking about the cost effectiveness considerations. The NASA handbook says that the objective of system engineering is to see that a system is defined, built, and can be operated so that it accomplishes its proposed safety in the most cost-effective way possible, considering performance, cost, schedule, and risk. We have included here this graph from IBM in this case, talking about the requirement as the reason for failure when the errors are identified in the design process, and when those defects can be discovered. In this case, we see in the red line that the defects are introduced mostly at the beginning of the project phases. So 70% of the defects are introduced at the beginning, when later on further phases are lower introduction. But at the same time, if you see the green line, the detection of those defects are not in the earliest stage, but later in the test phase and at the end in the operational phases. The intention of our tools is to try to join those 2 points. So with our suite, we are able to decrease the introduction of defects and improve the detection. So we try to mitigate this situation, okay? Here in the right, we have included a graph from the handbook, from the NASA handbook, that is inspired in an in-course graph as well, where you can see that most of the cost of your projects are committed in the earliest stage. So as a sample, during the up to the design phase, even if you have consumed just 15% of your cost, you have already committed 75%. So that means that with the decision and with the concept that you have already developed, the 75% of your project costs are already committed. So changes for defects detected later will imply a big cost in your project. So, for instance, this guy from NASA, Stakling, says that the cost of fixing a requirement error discovered during the operation phase range from 29 to more than 1,500 times the cost for addressing that error at the requirement phase. So as much as we can mitigate this problem and work in this part of the project, we will save money and time to market. So that is our main goal, the main objective for our suites. Maybe all of you already know these kind of issues that the engineering face due to problems with requirements. For instance, NASA has these problems with the NASA Mars Climate Orbiter because of a consistency problem. Or for instance, the European agency has as well this problem due to consistency with the Scarapelli lander. All of us know problem in engineering projects due to these issues. So okay, after this introduction, I want to talk to you more deeply about what is an ontology and a knowledge library for our organization. For us, an ontology is a combination of knowledge items of different nature and a different level of abstraction, representing a specific business domain or area of knowledge. Okay, with the aim of improving the way projects are managed, including quality, archive, and retrieve assets. Thus, provide tools to reuse those assets at different levels, reduce time to market, improving the way the engineers outsource the new assets, enhancing the way it are inspected and verified, enabling real interoperability between different platforms and systems, and reducing time to elaborate those documents, systems, and projects. So we distinguish 5 layers in our ontologies and knowledge libraries, starting by the foundation, let's say, of this building. We have the terms, the vocabulary in the first layer. Those are controlled organization and project vocabulary for a common understanding among the shareholders. Then on top of that, we have the second layer, where we establish the system conceptual model and the architectures. So we capture the system relationships represented in several views and models, and we are able to put together those vocabularies and start to making related to each other with relationships, with classifying, making groups, and so on. Later, we have the third layer. We are very happy with the patterns we use a lot, because those patterns, those are templates representing a set of agreed upon templates, grammars to create and maintain consistent textual artifacts. So with this pattern, we will see that we will be able to do some advanced semantic characteristic. Okay. Then we have the formalization. The formalization is the representation of the assets, semantics, so SRL, system representation language, that are able to extract from the patterns the properties of the values or the relationships from our documents, okay, from the textual documents. And at the end, we have the reasoning, that for us is how the machine is able to work with this information extract from the documents, and is able to assess and to elaborate metrics that can help us even in authors or in checking the quality of our documents. Okay? This is an example of a knowledge library. So we have in the right side what is the common language words. We support several languages, in this case English, and this is the common terminology that is managed by everybody. But we have in our knowledge library where is the domain-specific terminology. So at vocabulary level, we will have, in this case, is an example of a aircraft environment. We have several terms that are specific for the domain. We have also, in the second level, system conceptual model, the relations that could generate between those terms. And we have, for instance, a range of temperature, or we have here an aircraft that can be of those types and can be composed by these parts, okay? And even this aircraft is a system, and with this system conceptual model, we start to build our building, let me say. After we got the 3 layer, which is the pattern, it's a grammar template made by different slots, and where we are starting to place different terms from our vocabulary, even common English or domain specific. In the following layers, formalization, we are able to extract information using this pattern and start formalizing, extracting information from the pattern. So we are able to identify the data, variables, measurement units, relations, and so on. As this one is temperature is greater than minus 70 degrees, Celsius degrees. And after, with this information in the reasoning, we're able to establish metrics or to extract information and operate this information to give us the result that we pretend, automatize the calculation and the information. So this is our building with the 5 layers. What we have done from the book? Well, we have created this ontology, first extracting vocabulary from the handbook, and from in this case, we have used for the demo, as you will see, a document with requirements for the James Webb NASA telescope. So we have introduced the information coming from the handbook and from this document to create our specific domain vocabulary. Okay, so this provides a consistent way to name and understanding all the concepts across this domain in this case. Okay, we have introduced, for instance, as a terminology with then the term and the scope note telling what is the term, what is the meaning of the term. Then we have introduced as well some relationships in the conceptual model, as we will see in the demo, okay, as could be clusters or several views. This provide means to fit the textual pattern and help author while the right requirement of the types of textual assets. We have also this kind of taxonomy in the system conceptual model as PBS or organization hierarchies. In case of patterns, we have included most of them to elaborate our metrics. Our metrics can be based on patterns to extract information from the document. As well, we will see we have patterns to help the authors to match the template that is proposed by the handbook, and to allow the authors to write at the first time using a template, authoring template. And at the end, we have the formalization. No, well, not yet the end. The 4th layer is the formalization, which extract properties from these patterns and from the documents. Then with this formalization, we are able to reasoning and to extract conclusions. Okay. What libraries we got? Well, those libraries are public in our website as a resource, and we have created some of them to help our customer to explode in their suites We have in COSE library with the latest version of the guide for writing requirements. We have a webinar, 2 webinars ago, there was for this topic. So if you are interested, you can see from the web. We have EAR patterns library, ECSS library, the NASA, as you got now. Some ISO for automation, and for instance, another for master patterns, which is a standard for templates. Those, the NASA library we are working today would be available in some days, and some weeks in our web. Okay. Well, I'm going to show you a little bit what is our system engineering suite and what are the products that make the environment. All the suites are based in the system knowledge repository, where we have the system knowledge base and the system asset store. So we have tools using this sensor information, and we have the Quality Studio, HRQA, which is able to set up, check, and manage the quality of the requirement. We will see in the demo how it works. We have also the RAT, Rich Authoring Tool, which helps the author to create the assessment, to create the requirements. And we have the Knowledge Manager, TM, to manage the ontologies, to manage knowledge around a requirement specification, the historic glossary, concept map, knowledge models, ontology, and packs. So it's the tools able to build an ontology and to modify it and to create it, to edit it. Okay. Our tools are able to connect to other external tools. So for instance, HRQA explode requirements coming from different sources, different knowledge management tools, because our suite doesn't contain the requirements. Our suite works with the requirement coming from external repository. We are not a requirement, we are not yet a requirement database management. So we can connect with doors, with Integrity, or even with Excel, as we will do today, because we have translated requirements from the PDF document with using a parcel to an Excel file. Also, for instance, our authoring tool has some plugins that can be connected with those tools to directly author using our RAT with the enhanced authoring inside of the requirement management tools. For ontologies, for knowledge management, our tool is able to connect to external repositories for ontology information, for terminology, system conceptual model, and so on. Tools as Rhapsody or MATLAB Simulink or MathDraw and Protege, etc. What we will do is not to copy the information in our ontology, but keep the connection with the external tool, so we are able to keep online information and not to have to copy every time. So we save the connection, so the information will be fresh every time that you use your KM. Well, how we can make this mapping with our metrics, with the NASA guidance? Our metrics has an approach of this, what we call CCC, correctness, consistency, and completeness. Of course, correctness for individual requirements, and consistency and completeness for set of requirements. So for NASA, requirement is a shall statement and should be clear, correct, flexible to obtain unambiguous in meaning and can be very validated at the level of the system structure and which it's stated. So this is the concept for NASA Handbook, and those are our type of metrics. We can create metrics for correctness with those several types from the attribute, from a list of terms, for linguistic algorithms, conformance with models based on patterns. For consistency, we can establish metrics with each other, with models. We can find duplicate requirements. We can search by expected ranges and confirm that our values are in those expected ranges. measurement units, property allocated as power, weight, or whatever, or run transition for state machines. We can make a lot of kind of consistency metrics. And for completeness as well, we can establish several kind of completeness, requirement type, key concept, check for all the elements of the system, of signal levels, states or models, and several for this completeness aspects. Patterns, as I mentioned before, is very important for us because it's the feature that helps us to extract information. And we have some specific webinars talking about patterns. You got here the links, so you will be able, if you are interested, to learn more about how we work with patterns. Okay. But just let you know that with pattern we are able to do advanced search, and with this mechanism, for instance, as we will see in the demo, we're able to detect things like the passive voice, not in general, as maybe you can do with searching by terms, but in this case, our tool is able to establish in which part of the sentence the passive voice is established. For instance, the passive voice is bad in the main sentence, in the main part of the sentence, but not in the condition, okay? Because for the condition is not a problem, it's not an issue, but it is for the main part because, you know, the subject who is in charge of to make the action is not clear with the passive voice. Or as well, we can do this kind of distinguish. In this case, the word around can be a base term, but can be also a preposition to establish around something, around an X, around the curve of a minimum speed, and so on. So will be an imprecise quantifier in this case with a number, but not in this case as a preposition. So from the information coming from the handbook, we have extracted these characteristics and we have created a metric map, a mapping of metric. So from each characteristic of the guidance, we can assign one metric we have created and we have given these numbers. In some cases, with one metric, we tackle the characteristics, but in some cases, we add more than one to cover these characteristics. Or in some cases, we just say that we cover partially. It's not a full cover, but it gives you a help to establish the characteristics. In other cases, we say that we are not able to help you with these characteristics. So we have a full map. You can check in the presentation about what metrics, what functions we do to cover the handbook guidance. Okay, for all the topics that the guidance give us. Okay, and now I want to show you a little bit in a real demo how it works with our tools. Okay, I will show you an example of some metrics. So let me hold on a moment because gotta. Oops. Sorry. I got a problem here with my. Sorry, just a moment, please. Yes, that's it. I will play a video, but I will talk on top of the video. So we are opening now the KIM, Knowledge Manager tool. You have to establish a connection to the database. You have the different types of database. In this case, we are going to use an Access, but it can be MySQL or SQL Server or whatever, or Oracle. Your organization databases. So when you open your knowledge management tool, you will see what we say the first layer, the terminology. Here you can see all the terms that we have included in our domain library. Those terms have been extracted from the document and from the requirements from the handbook and from the requirements document, the JS Web Telescope. You can see here that we have clusters to group the terms. In this case, we have created a NASA cluster with more than 800 terms, which have different type of terms. We call term tag, noms, acronyms, adjectives, or different types of terms. Okay, for instance, for adjective we have more than 500. You can search in this window. You can sort by different concepts, and it's the way you manage your vocabulary. Also, there are some import tools to help you to build this. In the system conceptual model, the second layer, we can create hierarchies. We can create relationships as the organizational view, but as well the product breakdown structure view, with in this case JS Web System Telescope PBS. Okay, and you have many other views you can create and store your relationships. Okay. In clusters, it's very important to group the terms. We have these tree organization because the clusters are organized in trees. For instance, inside NASA, we got all these groups, NASA acronyms. For this time, we have 392 NASA acronyms. We have strat. You see the meaning of the acronym. Sorry. And well, other terms organized in different, for instance, documents, instruments, terminology, and different groups that later we will explode this group of information in different ways in our metrics. Okay. We have patterns. Those group of patterns. Well, you have patterns and also group of patterns. Most of them in this case are to help us to assess the metrics, to extract information, and to ensure the alignment with the metrics. But as well, as we will see, we have patterns to help the authors. So those are templates to match during the author process. In the formalization, we extract information from the documents using the patterns. We can start properties and we can start relationships. Okay. Those patterns are organized in pattern groups because we sometimes need to assess from a group of patterns, or you can have a group of patterns for authoring, as you can see here, for those several types of requirements: functional requirements, performance requirements, environmental requirements, and so on. Okay, now I'm going to show you the RQA, which is the other tool of our suite. You have to also make a connection. In this case, you connect the ontology, the database library ontology, with the document. Okay, so you need to specify what are your source of requirements. Can be doors, can be integrity, PTC integrity, or other kind of sources. Or just a simple Excel table with a specific template to store your requirements. Those requirements, as I mentioned you, was started from this James Webb Telescope project. This is the public document from NASA. And here you can see that they are clearly defined with a unique code, those requirements. So we have extracted using a parser tool those sentences to an Excel file to be connected with our ontology library in the ArcWay tool. This is the file and this is the library. So we open the connection and the ArcWay has these three main menus: quality assurance, workbook operation, and quality control. In quality assurance is where we can establish the metric set baseline, is what we call. In this case, we have just one metric set baseline that you can create as much as you need. For instance, we can do a smooth approach, making one more simple metric and then create it more advanced one. We call belts, white belts, and like in the Mars app. Inside of these metrics baselines, you have the three approach: correctness, consistency, and completeness. And here is where you establish the metrics. You give the name of the metric, and you are able to create the versioning of the metric. The metrics can be from several types, as I have shown you before in the presentation. It's very easy to create a new one or to parameterize the one that already you have. Okay, so you can play with this and create as much as you need. In this case, we have 38 metrics for correctness, enabling 31 because the rest are depending on information that we have not available in this document. So, but it depends of your resource. If you are connected to doors and you have several attributes for the requirements, you can establish more metrics. Here below you have the quality function, which is how to evaluate the result of the metric. So the quality function is what gives you good quality or bad quality depending on the result of the metric. Okay. In this case, some of the metric has just a binary result, so it can be good quality or bad quality depending on the results. But you can make it in more stages. For instance, in this case, which is checking the text length, we have set these 4 steps for ranges. So we have bad quality, which is less than 4 words, so more than 61. Good quality between 4 to 56, and medium quality between 36 to 61. Okay, this is of course parameterizable depending on your needs or your organization criteria. Okay, so you can establish. In this case, for example, we have 3 steps, which is the metric is check the number of modal verbs in your requirement. So if we have less than 1 or more than 1, we have bad quality. But so you have good quality if you got just 1. Okay, because this is the atomic criteria. Okay. This is the way to add new metrics from different types of metrics based on the system conceptual model, based on the attribute of the requirements, or based in different concepts, okay, from your documents. Here on the right, you have the authoring patterns, and as well you can set a metric to what you call a style guide to ensure that all your requirements match one of those patterns. But those patterns also help you to author. In this window, workbook configuration is where you assign the metric baselines to the document. In this case, it's very straightforward because we have just one document and one metric baseline, so it's very easy. But you can manage here several baselines with several documents, so you can assign to different documents different type of different set of criteria, different set of metrics. Okay, in this case, it's very easy to assign 1 to 1. Also, here you can manage the properties of this assignment. because you can save the quality back to the source of the requirements. In this case, save back to Excel. But if you are connected to doors or to ETC integrity, you will save back the quality. So the doors will also keep the quality in a specific view from the tool. Okay. And in this quality control menu is where you can see your requirements one by one and the results of the assessment once you run the assessment based on the metrics assigned to your document. Okay, so if you run the assessment, you can run the full assessment or by characteristic. By consistency, completeness, or correctness. In this case, I have run the full assessed. As it's the first time, it will take a little bit more, but normally when it's just updating, it takes less. Now it's going through all the requirements and checking the metrics. Okay, we got now the results. They're now presenting the results in our window. All right, so you can see here the results for correctness and for consistency with 1, 2, or 3 stars. In this window, you can search, you can sort, you can create different filters to see what is the result of your assessment, which one are getting good quality, medium quality, or low quality. Okay. And it's very easy to do filter and so on. Apart of being watching the requirement, you can see also check by metric. If you go to this option, you see first a statistic, all with the full information of what have been the metrics with having issues or with not, which requirements are affected, and so on. So you can see what are the most metric detected, or the less one, or the one that has not mistake at all. Most frequent errors, least frequent errors, and here as well you see the total result of your asset in this case, with high, medium, and low quality. Here you can open the metric and see more detailed analysis of what requirement has been found wrong. For instance, if I check this metric, I can see here which was the problems and the number of issues that was found, and I can navigate directly to the. We can see here the requirements, filtering the one that didn't find problem or the one that got problems. And you can also navigate to the requirement to see what is the sentence, and even to open the requirement, and you can modify here the requirement and save it. Okay, so this is a window to edit requirements, and you see here that you have on-fly assessment of your quality. So you have here the results of which metric has been found problematic. In this case, he found shall be arranged. The size and guide FOBs shall be arranged in a not overlapping fashion. So it's painful in this case, the passive voice, because it's in the main action of the requirement. So who is gonna take a charge of this action? Okay, so for me, this is a not good requirement. As you can see, you can directly, we will see later, directly changing the requirement here and modified it, and it will give you on-flight assessment. Well, we have also a problem here of punctuation because it's quite long requirement without any punctuation that it can be difficult to understand. In this case, this is just medium quality, and depending of the weight of each characteristic, you can manage that as well. The result of the total result of the assessment for one requirement can be managed. You can establish some metric as mandatory or not, or just making a total assessment based in each metric result. We have here another example. This has good quality, even if the requirement has a problem with the punctuation as well. But as it's not mandatory, the result of the requirement is good, but the tool is alerting you that maybe you will need to modify the punctuation in this case. The rest of the metric are found okay. In this requirement, you got the word about, which can be a vague term. But as the tool is detecting that the word is using not as a preposition, the observatory is orbit about L2. L2 is an axis for the orbit. So in orbit about an axis is an okay use. But for instance, if I remove the L, as you can see, automatically the tool is telling me that about 2 is an vague use of the word. Okay, and I got two metrics in this case about the use of vague terms and about the use of imprecise quantifier that are telling me that these are not good use of this is a not good requirement because about 2 is not precise. It's a vague definition. But about L2, the observatory is orbit about L2 is a good requirement. Okay, so this is thanks to the advanced semantic search that we can do through the patterns. Another example here of these characteristics of these features. If I here got a number less than or equal to 500,000 kilometers. If I remove the word kilometers, the tool is telling me now that I have to ensure that numbers are following by a unit or a quantifier. So I got a number here and 500,000 what? I have not any character, unit associated to the number or any quantifier. So if I wrote a number 3 without 3 what? 3 engines or 3 meters or something. Okay, if I don't put the unit or the quantifier, the tool is telling me that you have a problem. Okay, so this is another example of how our metric can help you to detect defects on your requirements. Well, I will show you here the Excel that we are using, and as you will see, the quality assessment is also saved back. You see here the results, low, medium, high quality, the time of the latest assessment that was a couple of days ago, I did it, and a summary of what was the issue found. Okay. As well, if you use DOORS or Integrity or other repositories for sources, you will see the quality back in those tools. Now we are going to open the RAT tool, which is oriented to the authoring. We need to create as well the connection.
with the same type of connection with the ontology and with the requirements document. Okay, so we open the connection, the tool, and we see similar window, but in this case oriented to authoring with the already assessed quality. And here you can create new requirements, to edit existing requirements, and also to see quality assessment. So if I create a new requirement, I can use the patterns to help me in to match the model, the template that my organization has established for my requirement. I got here different, well, you have to notice that when it's empty, we got an empty requirement, the tool is already checking the requirement and it's telling me that they have not enough length, for sure. It doesn't have a model verb, okay, because it's empty, but the tool is already checking my requirement. So I have three metrics yelling me. So for start, I can choose what kind of requirement I want to write. Sorry. So I have here the different types of requirement I have defined in my ontology. Okay. So I will choose a performance requirement. And the tool offer me a pattern to be matched. So it helped me with the slots, with the option for each slot I have to choose to match the pattern. Okay. So if I start writing, the tool is giving me the options that I got. For instance, so now it will offer me the possible entities or possible words that again here. If I start writing, they search and sort the options. So the ground segment, child. So you can write the requirement based on the possible options. As you can see, we have a square. Now it's yellow because you have not matched the pattern yet. You are in the way, but you have not finished the pattern, but you are going well. Okay. As you can see, the quality is being modified. Now doesn't appear the previous advice because we have already a model there and the length was better than before, but still is giving me some issues. I can finish writing the requirement. The ground segment shall provide a current of 20 amps. In this case, now I have matched the template, and that's why I got this green square. Okay. I can play here. Well, it still is giving me an issue because I have included a unit, 20 amps, and this unit I have force in my ontology that need a tolerance. Okay, because I configured like this. You can put it other units, so you can remove. It's up to you. But for this example, I have included the intensity, the amps in the group of units that require a tolerance. Okay, so if I don't put a tolerance, I will have this not good quality metric. So the tool is checking if I have included or not a tolerance. As you will see, if I include here some range, 20 amps plus minus 30%. Okay, so I have included the tolerance. I don't have now that issue, but another one that I have included, the tolerance is higher than expected. Okay, so I got another metric for ensuring the tolerance is in adequate range. For sure, I can configure this range. I can include this metric or not. It depends on you. So for me, 30% is too high in this case. So I can modify this tolerance to accomplish the right range. Okay. So those are just examples to show you that we can use the values extracted from the documents to reasoning and to obtain results. So I have put now 1% and, oh, sorry, it's too low. They are not range for this metric. So it's 1% is too low for my definition. And with 3% now it's okay. I got high quality with this tolerance. Okay, so just matching a range, sorry. And this was another example. Okay. In this case, I will not save the change. I can also make a new requirement based on free text. I don't want to follow now a pattern, so I will write an open text requirement. So, for instance, these texts are invented, maybe stupid text. Or in the observatory, you see the metrics are already working while you are writing. When the observatory displays it on a trajectory, so when the observatory is placed on a trajectory, the launch vehicle shall be located. I got here two passive voids, okay? Should be located to the operational orbit, okay? I got one here in the condition part when the observatory is placed, okay? And another one here, the launch vehicle shall be located, okay? Shall be located for me is a problem. And you can see now the metric just give you this second passive void as a problem. Okay, the first one is not an issue, but the second one it is, because you don't know who is in charge of doing this action. So it's another example of how we can assess based on the semantic search. Now another example for consistency. We have seen most of the examples for correctness. In consistency, we have these two metrics. One is to avoid the use of different unit systems. Remember the problem with the NASA orbiter? There was a problem with the consistency of units. In this case, this JS web document has not any problem in this consistency. All the units are from the same unit system, but I can change one of the documents to create an issue and to see if our tool is able to find it. For instance, I will look for a distance unit, kilometer, in one of the requirements, for instance, in this one. And I got here this number to less than or equal to 500,000 kilometers, okay, the one that we see before. If I change kilometer and put an imperial unit, mile, okay, and I save the document, the requirement, I check again the consistency. I will check it just consistency in this case, not to run the full assist. it's now verifying those metrics. And if I go to see the results, now the metric is telling me I got a bad quality. No? Something changed. And I can open the metric and check what is the issue. And it gives me that in part of the requirement are using international system metric, when in the other part we are using imperial. So we have one requirement using imperial and for distance, and in the other ones you are using international system. So it tells you that you have an issue of complete consistency with your requirements. Okay. So that is all. This is all I want to show you for today's demo. So now, please, Cecilia, if someone has any question, I will try. Sorry for being a little bit longer than expected. I will try to solve briefly some of your question, or if you can send us also mails or whatever to ask for any of your questions.
Thank you very much, Luis Javier. So if you have any comments or questions, you can send them through the chat box to the Regis company or to everyone. I will give you a couple of minutes to write down your questions, and meanwhile I will tell you about our next webinar. It's called A Practical Way to Implement ISO 15288 V&V Processes, the V&V Studio. The ISO 15288 clearly defines what must be done when performing verification and validation processes. We must use and manage verification actions and collect evidences. But how should we do it? How to integrate them all in one environment? How to delegate V&V to specialized tools for specific work products? How to deal with interoperability? This webinar intends to provide insights for these kind of questions. Our tool, V&V Studio, merges the three concepts: verification, validation, and quality, and offers V&V by managing the corresponding verification and validation actions through quality and other measures. The dates for this webinar are the 2nd and 4th of June. So let's see if we have any questions. How do you build these ontologies? Is it automatic extraction from documents, or how do you do it?
Well, yes, I didn't talk much about this. Yes, we have some helps to create the ontology. It's not manual. We have import tools to pass the information to the tool, even terminology or even hierarchies and relations. And also we have some specific libraries to extract information using patterns. So we are able to automatize the process to build this kind of libraries. You can do it manually, of course, but also we have helps, we have means to help you in building the ontology. It's something that the organization needs to care about and to establish, because it's important to fix what are your terms and the use of relations that you want to establish. Normally, there is a role in the organization to manage the ontology, where other roles are outsourced, are just checking and writing requirements, and can suggest changes to the ontology, and the ontology manager can accept or not I didn't show you this feature, can accept or not the suggestion. Okay, so you are helped to build the initial ontology, to modify it with the KM, and also to manage the suggestion from your organization. If you have more doubts about this help, you just contact me and I can try to explain you further.
Okay, thank you. Also, you were talking about public meta handbook guidance, but is it possible with transfer learning between different companies? from the technical or legal point of view?
Well, yes, in this case, we have used a public document to create this ontology. This ontology is available in our web, and it's what we call a domain library because it's based in a, let's say, a standard. Most of our public libraries are based on standards. For a specific ontology from a company, well, I suppose that there should be an agreement between companies to share this knowledge, because when an ontology is part of a company, it contains the knowledge of the company. So, well, this is a private agreement between them to be able to share this information. I mean, technically, it's very easy to share these ontologies, but it's just depend of the politics of the companies. Okay, we have created a domain based on standards, but for more specific company information, it's just a question of the companies. More questions, Cecilia?
No, we don't have any more questions. So thank you very much, everybody, for attending. If you have questions later or want more information about anything, don't hesitate to contact us by email to contact@reusecompany.com or to our website, reusecompany.com. You can also find us in YouTube in our channel, The Reuse Company. Thank you very much and goodbye.
Okay, thank you, everybody. You got here my contacts as well. If you need further information, I'll be pleased to help you. Thank you.